Maclafferty rearrangement, one of the rearrangement in mass spectroscopy. A molecule which contain unsaturated bond or a lone pair of electron also having gamma hydrogen atom. In this case, this is our functional group and this is alpha carbon, this is beta and this is gamma carbon. Gamma carbon must contain at least a gamma hydrogen atom. This kind of molecule, whenever we bombard a energetic electron of energy 10 to 15 eV electron volt energy, then the loosely held electron of this molecule will knock out. As we know that the pi bond, in this case the pi bond is loosely held, so one of the electron will knock out from this position or this position, because the double bond means it possesses two electron. Whenever we bombard a energetic electron, then it will form cationic radical. The compound, after losing of two electrons from this compound, a cationic radical is formed. At this step, a hydrogen is transferred, gamma hydrogen is transferred from a charge side to or towards the charge side via transition state having six-membered transition state, or we can say sterically hindered six-membered transition state by the migration of the gamma hydrogen. So we can write in this place, at the gamma hydrogen will take place the homolytic cleavage, and this hydrogen radical will combine with this radical, carbon radical. Now it will migration of hydrogen atom and this position having positive charge, and due to homolytic cleavage of this bond, one of the electron goes to this carbon atom, so this carbon atom became radical. Now under the influence of this radical, the cleavage of this is our alpha position and this is our beta position. The cleavage of beta bond or alpha beta position is cleavage. Under the presence of this free radical, this bond also start to homolytic cleavage. One of the electron will goes to this place and another electron goes to this carbon atom. After the transfer of this electron to this place, these two electrons will form a double bonded compound which is a neutral one. This will form a ethene molecule. This electron and this electron will combine to form a ethene molecule, and this compound became possessing hydrogen atom having positive charge and free radical. So this one became cation free radical. In mass spectroscopy, we cannot distinguish or identify the neutral compound, but this cationic free radical is identified with the help of mass spectrophotometer, whose m by z ratio or m by e ratio, in this case z is equal to +1, so or charge is equal to +1, but the mass became, initially we have two hydrogen here. Now one hydrogen abstracted from here, so we have here 3 hydrogen atom, and in this position we have one hydrogen atom, and this carbon, alpha carbon, contain 2 hydrogen. So in our product part also 1 carbon, and this alpha position occupied by 2 hydrogen atom. Now we have the molecular mass value on this carbon, second carbon, third carbon, it will become 36, 12, 12, 12, 36, plus we have 2, 3 plus 3 hydrogen here, 6 number of hydrogen. So its m by z ratio became 42. 36 plus 6 hydrogen atom became 42. So the signal will appear at 42 m by z position in mass spectrometry.